Ciao friends! In this video we're going to see how to create a calendar based on weeks with Power BI. But first of all, why should we use weeks instead of months? Well, this is a common requirement in many businesses. We will see some example of the reasons that could lead to this decision, and then we will implement different calculations at the beginning based on months and then based on weeks, obtaining the corresponding date table in a quick way, for example, by using Bravo or by using the auto-date time in case you want to use the regular calendar, even though this has some limitation, of course. At the end, I will also show you a workaround about how to create a comparison based on weeks without having a calendar based on weeks. Let's start with the demo. So before starting to see the different type of date tables and calendars we could use, let's take a look at the use case where a difference between a week-based analysis and a month-based analysis is important. Actually, there are industries that are where it's very common to use week calendars. Retail, manufacturing are very sensitive to the number of working days or to the number of days over the weekend and holidays, for example, because this affect the metrics that we want to analyze. In our example that we want to share with you, we got the page views of a website that have a trend that is clearly defined by the working days. So if we take a look at the result before starting to see the different type of analysis, this could give a better understanding of why this kind of analysis is important. So we see here the number of page views of a website, and you see that there is a clear trend where during the weekend, during Saturday and Sunday, the number of page views drop to a much lower number. You also see that there are two lines. One is the dark blue, that is the number of actual users that are visiting the website, and there is another number that is an isolation of the number of page views generated by bot. And so a bot is a robot that is actually visiting the website, and you see that the trend here is not clearly defined by the weekends. You know what? Bots don't have weekends, they work every day. So this is what we see in this website. Clearly, this is a website that is related to the business, because in a website dedicated to sports, we will probably see an actual opposite trend. So we will see an increase during the weekends and a flat, a lower number during the working days, hopefully. But that is what we have to analyze. Now, if we look at the value day by day in this line chart, we can clearly see this trend. But at the same time, while we can observe this trend, it's harder to understand whether we have an average that is increasing, decreasing. It's harder to analyze the trends with an aggregation of days, like a week or a month. So what happens if we take a look at the value aggregated by month? Well, what we see is that we have a much flattened line, and you see that there are differences, but actually, especially when the differences are so small, is the difference between January, February, and March caused by something that actually happened, or perhaps February has a lower number of working days, so in relative terms the increase is bigger than what we see? So these are information that could be important, especially when the small differences like 2-3% are important. And we can get an idea of the numbers that are in play if we take a look at the value also using the numbers. But before doing that, let's see what happens if instead of using one data point for each month that aggregates the data for the entire month, the number of page views for the entire month, I get another report that I already prepared where we see the trend by week. We see a data point for each week, and so we can see better that there are actually differences between different weeks, which is no longer a flattened result like we have seen before. So, well, actually, there could be bigger differences if we look at the data at the month level, even though probably we will not see a big difference in the line chart, but the difference could be visible in the numbers in a way that could be significant for a particular business. In order to see these numbers, we can take a look at what happens if we aggregate the value, the week's value by month. We will see later that what does it mean looking at the value by month? Because actually when we see the value, for example, here for April 2024, is not actually from the 1st to the 30th of April 2024, because this is a month based on weeks. So it has to be a 4 or 5 week month. We will describe this later. But the idea is that if we consider this period that we call April, the difference is 6% over the same period in the previous year. So we are doing an year-over-year comparison. This is the measure that we are using, and for the year-over-year comparison, we see a number that is increased by 6%. I try to highlight this better. So this is the number that we want to analyze, plus 6% over April 2023 with the week-based calendar. If I use the month, so if I go back to the previous report where I have this calculation based on month, we can see that the value for April, here we go, is plus 13%. So from plus 6% to plus 13%, big difference, right? So the increase is doubled if we consider the month. Well, actually, we are considering different months, but again, we are considering also a different number of weekends in the comparison. And so this is probably this could be the reason, maybe that in April 2024 we have more working days than April 2023, for example. And so this is the kind of problem we want to face and want to resolve. By using a calendar based on weeks, we can neutralize these differences and makes the comparison more efficient. And so in the next part of the video, I will explain how to obtain each one of these different results, the different charts and calculation. And we will start with the auto date time, then with the Gregorian calendar, the solar calendar that we can create in a very automated way. We will do the same for the week-based calendar, and at the end, I will also show a different type of comparison that doesn't require a particular calendar, in case you need to do something very quickly, but they still provide a meaningful result. So the model that we analyze is just one table. We have an Excel file, one Excel file with 3 columns, date, client, and number of page views, one row for each day and client. So for example, for the 1st of January 2019, we have 3 rows, and we're interested in classifying the client type that created those page views. We want to analyze the browser, which are page views generated by real users, hopefully, and we keep the both separated because we know that the both have a different trend of analysis, and we want to ignore them when we do certain analysis. Also unknown is something else that we will probably want to ignore. The range of dates start from 2019, and we have dates until the beginning of September 2024. And we just import this single Excel file into Power BI. So in Power BI, the model we have has only one table, 3 columns, and exactly the same numbers that we have seen before. Well, date, client, page views, we can just create a line chart. So if I use in a line chart the date in the x-axis, the page views with an implicit measure that sums the page views for the y-axis, and I use the client in the legend, so I split browser, unknown, and bot. I get these 3 lines that have a range from 2019 to 2024. So this is the range of days we have. Now, you can see that there is some up and down, so actually something is happening, but the first thing that I might want to do is, for example, to analyze a smaller range, because otherwise I cannot see exactly what is happening. So let's try to filter, for example, only from the January 1st, 2023 to the end of 2024. So I could apply a range of dates, like, for example, a relative date. No, I want to do an advanced filtering greater than on or after this one. Let's use the 1st of January 2023. So I go back in 2023 and I choose January. So just to see, something that is similar to the chart that I showed you at the beginning. As long as I want to see the data grouped by day, this is the way to go. But actually, what if I want to see the data by month, and I want to compute the year over year, month by month? So I want to compare, for example, April 2024 over April 2023. Well, first of all, I need to show the data by month. And in order to show data by month, I need a date table. Now, the first thing I can do is to create a table automatically. I can ask Power BI, create a date table for me. So the way I can do that is the following. So if I go in File, Options and Setting Options, actually what I'm going to do is something that usually is enabled by default. This auto datetime time intelligence by default is enabled in Power BI, but on my machine, because this is not the best practice, I disable this auto datetime for new files. So because I just created this new file, this is disabled by default. But let's see what we can do if we enable it. So when we enable auto datetime, what happens? You notice that in this area of the model, we have actually now this new date hierarchy that appeared. So if I increase this a little bit and I expand it, you see that I have this year, quarter, month, and day. What is really happening is that Power BI extended this data model for me. So what happened is that now there is a date table here. So there is a date table somewhere that I cannot see, but the table is there. And this table has been connected to the date column in page views. This table is hidden, but is there. And in my model, what I see are just 3 columns that have been created by Power BI for me in this date table. I cannot customize it, but the table is there. Now, by having a date table that has a column month, I can actually use this column by creating, for example, a new visualization with a matrix. So let's create here a matrix where I want to use, for example, the entire date hierarchy, for example, here. And I want to use a matrix because I want to use the page views here. And I want to use the matrix, please. So let's try to create this way. So now I have my sum of page views. Let me fix the number so that we see this number in a more readable way. And actually I want to sort by year. And I want to see 2024, quarter 2, and April. I can get rid of the quarter because I just want to see the month. Sorry for this, because the Power BI decides that he doesn't like my visualization, and I can see the value of April. So now my goal is to display the year-over-year percentage. The reason why I wanted to create a date table is because, first of all, I need a date table, either an automatic one or one that I will create later for me, to see the data grouped by month. But then if I want to create a comparison, I have to create a DAX measure to do that. So I can create this DAX measure by creating a new measure here, and I can create my year over year, so number of page views with, let's start to create the measure. This is a measure, so the number of page views is actually the sum of the page views, so that I will use this measure later for my calculation year over year. So now I can create my measure, which I call number of page views year over year percentage. And I can apply time intelligence pattern that I can find on any article, and I can also use Bravo, but we will see this later. At the moment, I create this by myself, because in order to use Bravo, I have also to create a date table by using Bravo, which is the next step. I just want to show that I need to create this code. So for example, I get the current value is the number of page views I have in the current cell. Then I compute the previous value, which calculate basically the number of page views by getting the same period last year for date. Now, because we are using the auto date time, we don't have a separate date table, and in order to retrieve the date column of the date table, we have to use this syntax. We have to provide the name of the column date in the current table, dot date, and this is called column variation, which is the syntax to access the columns in the hidden date table that has been created automatically. Now the next step is I want to compute the difference between these two numbers. So the difference is the value that we have now minus the previous value, and the result is equal to the ratio between the difference and the previous value. So this is already the value I want, so I could write return result. That will work. But I could say, well, wait a minute. If I am in the first year, or I go in the future, and I don't have two valid values for current and previous, I don't want to show the comparison. So I could add an if statement that says, I want to show this value only when I don't have a blank value for the current value, and I don't have a blank value for the previous value. So if those two conditions are true, I want to show the result, otherwise I want to show blank, which is the default if I don't provide anything here. So at this point, I just format this as a percentage, actually, and I show the number in my report. Once again, I have to go back here. This is absolutely insane why it doesn't consider my choice. But anyway, so let's go to April, and now you see that we have this value that is 9.31%, which is the difference between April 2024 and April 2023 using this calendar. So far, so good. So now, oh, actually, this number is different from the figure that I showed you at the beginning because I'm including everything. I'm including the browser, the bot, everything. So I want to filter this client. So I want to add the client here. That should be a browser. Because if you remember, I said that April should be 13% if I compare month over month. So that's the number I wanted to get, but let's see what I did so far. So actually, I didn't spend time creating the date table because the date table was created for me, but I had to spend time creating the page view years over year percentage because I had to write the DAX code, I had to reference the column in the AutoDate table, and so that required me to write code, and if I had to create many of these calculations, it would take time. Yes, of course, you can use ChatGPT, you can use Quick Measure, you can use other tools to do that. But in the next section, I would see, okay, how can we take control of what we're doing? Because a big limitation of the AutoDate time, it's a good idea if and only if you have only one column of type date in your model in all the tables. If you have more than one date column in your model, also in different tables or in the same table, there are many restrictions to what you can do with AutoDate time in Power BI. You cannot create, for example, a line chart using two measures of two different tables using the same date. This is just an example, but there are many more limitations. So probably is a good practice, best practice, not to use AutoDate time in more complex models, which is the next step. How to create this table where in a way that we can control, but also without spending too much time. Okay, now I'm back to the situation where we don't have AutoDate time enabled, so I disabled AutoDate time. I removed the measure year-over-year percentage from the model, and I just have page views and the date. Because I don't have a date time, the date is just one row for each day, and you see the number of page views day by day. So the question is, how can I obtain the same result we obtained before, but with a date table that I can control? Well, I can do the following. I can just go to external tools and I can open Bravo. Bravo for Power BI is a free open source tool that we can use to create a date table. And this is just one click away. We can just say, well, I want to create a standard date table. I can see a preview of what is going to happen. I want to start my week on Sunday. You can choose Monday, for example, for Europe. We can choose the interval of dates. We want to get all the dates for the table that we have. We can choose other details. For example, we could include also holidays. It's not our goal at the moment. But one thing I want to do, I also want to include time intelligence functions. Why? Because the year-over-year percentage is something that is can be obtained out of the box by using Bravo. So with just one click, now I have, when I click Apply Changes, I have obtained two things. First of all, my model has now more tables. So we can ignore this date auto template table, which is a hidden table, we can ignore it. But you see that now we have page views and date. We just have to connect the date column to the date column of the date table. This is a one-to-many relationship. Now we can go back to our report and we can replace our date column with the hierarchy calendar we have from the date table. Here we go. Now we have 2024 and we have the value for April. The same value we have seen before, no differences, but you notice that now the name of the month is in this case written like 3 letters space year. And you can customize that. There are many things you can do with Bravo. You can customize the template and you can take control of the date table. Nevertheless, if you don't want to use Bravo, you can just modify the DAX code that has been generated to create this table if you want. This is, at the end of the day, this is a simple calculated table in DAX. But the other important element here is that if you remember, we wanted to create a year-over-year percentage calculation. Here we go. We already have the year-over-year page views that is already written for us and available here. Same result we have seen before. So we can see here April 2024, 13.45%. You see that the measure has been created in this area. Let me highlight this a little bit. We have this folder Time Intelligence that contains all the Time Intelligence version of the measures automatically created by Bravo for you. And if we take a look, this measure depends on other measures that have been created automatically, including the previous year page views, which is probably the one that is a little bit more complex. It's a little bit different from what we created before, but actually equally, it works the same way in terms of result. Is actually faster from certain point of view because it uses a more efficient technique to not display the data in case we go out of the range where the values are valid. This is just an example about what you can obtain with a single click. So Bravo is a tool that automatically creates the date table for you, and the advantage of this table is that you can customize it and you can also connect this date table to multiple tables that have a date column. And so we can keep a single date table, which is the best practice for a Power BI model. Now, the difference in terms of the result is the same. The auto date time case and this case with the separate date table provide the same result because in April we have exactly the same amount because we're considering from the 1st to 30th of April when we consider the month. Now it's time to see what happens if we try to group by week. Before creating a date table based on weeks instead of month, it is important to understand what does it mean to have a calendar based on weeks. So there is a standard called 445, which is basically the idea of creating a year that has exactly 52 weeks. And so this means 364 days. Which is 1 or 2 days less than the solar calendar that has either 365 or 66 days. The way this is organized is the following, and I prepared a simple report to explain how this works. So let's say that we consider 1 quarter in 2019. And then we have quarter 1, 2, 3, 4. So the idea is that if we have 52 weeks, we can divide the year in 4 quarters, each one with 13 weeks. Now, having a fixed number of weeks means that you have the same number of Monday and Tuesday and Friday and Saturday and Sunday, because you always have 7 days for each week. Now, if we have 13 weeks in a quarter, it means that we have 13 Sundays, 13 Mondays, and so on. So comparing 1 quarter with another quarter means comparing the same number of days, the same number of working days, the same number of weekends. And the consequence of that, though, is that the quarter cannot match 1st of January and 31st of March. For example, the first quarter of 2019 actually starts in 2018. So the first day, which in this case is Monday, I think. I don't remember if I'm using Monday or Sunday. Let me check. I'm using Monday. Okay, in this case, I'm using the ISO standard, which is an European standard that uses Monday. In the United States, usually Sunday is used as the first day of the week, so it's not complying with the ISO standard, but is equally a very similar technique. It's just a different starting day for the week. But in this case, the Monday is on 2018. And the last day for this quarter will be a Sunday. And this Sunday is actually exactly the end of March. But what happens in quarter two? Oh, in quarter two, we are so lucky because it starts on the 1st of April and it ends on the 30th of June. But then look at what happens in quarter three. Quarter three starts on the 1st of July, but ends on the 29th of September. So the 30th of September belongs to quarter four, and so on. Now, within a quarter, and the quarter usually is close enough to the actual quarter based on just a month. But when we look at how we split the quarter, well, we cannot split the quarter in months. We should say we split the quarter in periods, usually in 3 periods. Each one has a certain number of weeks, but the order of the periods that have a certain number of weeks is always the same. For example, a common standard is 4-4-5. So the first period in a quarter has 4 weeks, then the second one has 4 weeks, and the third one has 5 weeks. And the options are 4-4-5, 4-5-4, 5-4-4, because the total must be 13. Now we are using a 4-4-5, and for convenience, we named the name of the period like the name of the month, even though you realize that when we say January, we don't mean January. This is for this reason we see the prefix FM, fiscal month January 2019. So we're saying what we call January is something that starts on the 31st of December 2018, so the previous year, and it ends on the 27th of January 2019. We're saying that there are several days in January, the calendar year, that belongs to the fiscal month of February 2019, and so on. So you can see that for each month, we have a range of dates that is either 4 weeks, 4 weeks, 5 weeks. You see that March has more days than January and February. Now, this seems strange, but if you think for a moment, unless you want to compare one month with the previous month, which in that case will compare 5 weeks with 4 weeks, but when you compare any period of a quarter with the previous quarter, it works. If you compare one month of a quarter with the same month in the previous quarter or the same month in the previous year, you always compare the same number of days, the same number of working days, the same number of weekends. So it's actually a way to get a comparison that is like apple with apple and not apple with orange or something like that, because actually we are considering the same underlying number of working days. And this is the principle, right, of what we want to do. Now, how does it work? So if I go back to my model, if you remember, I created this model by using Bravo. So I am not the model, yes. I created the date table by using Bravo, and I connected the date table by creating the relationship in the model. Now, this is with the same model, so in the demo files, you will see different files, one for each example. But in this is the model I started with. I can just change my mind and I can go back to Bravo and say, look, instead of using standard calendar year, I want to use a monthly, not a monthly, I want to use a weekly calendar. So the weekly calendar is based on a system, in this case a 445 is the one that I want to use. I use January and Monday as a starting point just because I want to use the ISO calendar, but if you prefer to use a Sunday, you just change this setting. And I also change another parameter here because the way the week calendar is defined can follow different standards, and the standard can depend on the country where you live, on the company standards. There could be many differences. So basically there are a few parameters. Take a look at the documentation of Bravo to understand how they work. But basically by combining different options of these parameters, usually you are able to obtain the calendar that starts and ends where you expect. Unfortunately, the world is complex. There are many different options about how to do this calculation. And so in this case, I'm using the parameters for the ISO standard. But as I said, there are many other standards available. Now, once I did this, without changing anything else, I just apply these changes to the model and I go back. Now, because I'm creating a different date table that has different names, it's expected that my report stopped working because now I have the existing report is using column names that no longer exist because we have different names intentionally. We have different names in the calendar. So by removing the columns that have a different name, now you see I got rid of the hierarchy that had year, quarter, and month, or year, month, and day, something like that. I can go back to my model, and you see that the hierarchies are different. And for example, the hierarchy I want to use is this year, quarter, week, or year, month, week, because we wanted to compare by month, if you remember. So if I expand fiscal year 2024, you see that now I have April 2024, and the difference is 6%. Now, why this is happening? Well, if you think about that, the number of days is different. Actually, I think that there is a difference also in number of working days between the month, the full month, the 1st to 30th of April 2024 and 2021. There is a difference of 1 working day between the 2 months, which is not enough to justify the difference, but just to say that that difference in number of working days and the difference in the range of dates is what generates the difference in the percentage. So in this case, we're considering April 2024, which is 28 days, so 20 working days compared to 20 working days in the same month in the previous year, because it will be always another period in different dates, but very, very close, always with 28 days. So this is the explanation about why this works this way. Now, I didn't have to spend time creating the year-over-year percentage calculation. You see that the measure was already there, and because the measure is named the same way by Bravo, I didn't have to introduce the measure again. I just wanted to take a look at the code of this calculation. You see that the code is always a division between year-over-year and previous year. So the critical calculation is the previous year for page views, because here you see that the code is different, and it does not rely on the date column. It relies on the other columns, because Bravo understands how the date table is built and can actually filter the right columns, which are not dates, because it has to filter the same range of weeks that, or same range of days that has been selected, but within the relative position in the year that is based on weeks. And so that's the reason why this technique uses different columns. This technique is described in a DAX pattern that completely explain in detail how this calculation works. So this is not, the goal for this session is not to explain this calculation, but to make you aware that you don't even have to write this code, but if you want to understand how this works, or you want to customize it, you can just take a look at the corresponding DAX pattern for the week-based calculation on the website daxpatterns.com. Now, this is a way that explains how to obtain this different comparison, but what if you want to just do the calculation, the comparison based by weeks without changing the calendar? Now, this is the last thing I want to show you, but before going there, remember, if we use a week-based calendar, it means that our reporting in our company defines what a year is, and the only problem when we use the week calendar is that every 5-6 years we have 53 weeks in the calendar. If I remember, I think this happens in 2019, yes. No, this is, no, we have 53 weeks. I don't remember, there is 1 year, 53, here we go. So when this happened, for example, in 2020, the year has 53 weeks, which means that now we have here, for example, 6 weeks instead of 5. Which is maybe something you don't want, so there could be different challenges that you have to face, and I don't know so I don't see a standard used everywhere to manage this additional week. So this additional week should be ignored or not in the comparison. But the thing is that when you look at the year figure, it is made by 53 weeks. So if you use this as a standard for your company, this is the number for this year. I'm saying this because what we will see next is that we could just ignore the value of the previous year and just want to compare something that, even though it's a different number, is a number that makes sense for a comparison. We will see this in a moment. If our only goal is to make a fair comparison, we could consider another option, which is just subtract 52 weeks from whatever period you have. It seems strange, but you think for a moment, it makes sense. It is something that could balance better than other techniques what we want to achieve as a goal. Let me try to explain this with some example. We will see the same example by using all the different options. And the first one is the option with auto date time. Then we will see the Gregorian calendar and the week calendar. But the principle is the same. If you remember, when we created the page views in the first example by using the auto date time, we wrote this code. And if you look at this code, the only important part is this calculate. When we consider the previous year, so for example, we have April 2024, we want to get April 2023, what we do, we use this function, same period last year. Now, same period last year doesn't know anything about the calendar, but it receives a list of dates, and if these dates fits an entire month, then you get the same month in the previous year. That is how it works. Now, the thing is that this is exactly what you asked, but if we have, for example, in April 2024, we have 22 working days, and we have 21 working days in April 2023, this is ignored. What is inside those days in April? There are 30 days, that's it. So there is no way to say, no, I want just the same number of weekends, the same number of Mondays and so on. But because we know that if we go back 52 weeks, we go close to the same period, which is what we did with the week calendar, we could just change this part of the code saying go back 52 weeks. So I prepared a measure that does exactly this. You see that instead of using same period last year, I use date add, same column. I go back 52 multiplied by 7. I don't have week as a parameter of date add, but I can just convert the number of weeks in days, and I wanted to write the number as an operation to make it explicit that I'm going back 52 weeks, and I can compare the number side by side. So if I include this measure in this visualization, you see that for April, what I get is this number, which is 852%. Now, if you remember, 13% is the number we get from the month comparison, and 6 something percent was the calendar based on weeks. Now, why we don't have 6%? Well, but we are getting 30 days. So we are getting the same 30 days back 52 weeks. We are including the weekends. We are including 2 more days that are not included there. So we don't have the same number of Mondays and weekends, but the comparison is made with something that has the same content in terms of number of working days and weekends. So actually is a more fair comparison because this number is closer to the 6% we have seen before. Now, if you think about it, I don't need a custom date table. I can create this calculation with the auto date time like I did now. I can create this with the Gregorian calendar, the standard date table we created with Bravo. So this is the example where I used Bravo to create the month. You see from the name of the month that it is now April instead of APR instead of April. So this is what we have here. Let's go back to the. Okay, so now I'm back with the cursor. So we have here the value for year over year, which is 13%, as I said. And if we take a look at the value with the calculation that I created now, it is still 852% because this is still the same calendar that we created automatically with Bravo. Let's take a look at the comparison with the week calendar. So if I use the week calendar, you see that I prepared this calculation, which is the same calculation we used before, and now in this particular case, because the starting point is 28 days and not 30 days, the value is actually the same because, of course, we are comparing 28 days with 28 days, so it cannot be different, even though the formula we're using now is, of course, different because if I look at the year-over-year percent at 52 weeks, this one is using the date add that I shown you before. But the result is the same. We're comparing the same period in 2023. The goal was to show that the number is closer to the number with, in this case, identical, but in general, the 8% we obtained with the month is closer to 6% rather than 13%. So overall, if we are not interested in looking at the actual value using the comparison, but we want to see a percentage of comparison using the same, an equivalent baseline for a comparison, That is an option to consider because it doesn't require a week calendar. It can be applied to the regular month values. You have to just to be aware that if you open the report and you look at the value of April, is not the same value that you're using for the comparison. This could create some confusion in some user, but if you understand what you're doing, it's an effective way to get a fair number for the comparison. So we have seen a number of examples in this video. We have seen how to use AutoDateTime and a Gregorian calendar obtained with Bravo. We also have seen how Bravo can transform the same table into a week-based calendar, and how to obtain the time intelligence, the corresponding time intelligence functions without having to write any single line of DAX code. However, we might want to use DAX in case we want to use a workaround where we just compute the difference between two periods, even though they are obtained with the regular month-based calendar, but we want to compare apple with apple. We want to compare the same number of working days. Well, in that case, we could create just a measure comparing 52 weeks. You have many options, but as usual, enjoy DAX.